All right, welcome to this month's developer call with palfun-foslup. We are pleased today to talk about the terminal. Neal Stephenson wrote an essay 23 years ago entitled "In the Beginning Was the Command Line," and it encouraged users, and it recapitulated history and encouraged users to think about the increasing graphical abstractions that were being applied to interfaces, but that in many respects the command line was a more fundamental mode of interacting with the system. And to that end, we have been promised a new DIL, which we are here to speak of today.
That's right. Thank you for the introduction, Neal. Hello, everyone. I'm palfun-foslup. For a long time, the terminal has been a little bit of a pet project of mine in many ways. Actually, when I first started out at Tlon, the very first thing I did was work on the chat CLI application, the text interface for chat. And for the past year and a half, maybe 2 years, I've been working on and off on improving the terminal stack more broadly. Nowadays, every Friday, I retreat into my little hiding spot and work on new secret projects in this area. So, as you may have heard, many under-the-hood improvements to the terminal will ship with the next Kelvin upgrade. Rather than talking about all of those individually, though, I kind of want to walk you through the terminal stack and just point out some of the recent changes along the way. To help illustrate what I'll be talking about, I'm gonna share my screen here. Let's see, can we get this up there? Yes. And we're going to go into the terminal. So as you can tell, this already looks a little bit different from how it used to be. We have, the prompt we're familiar with, but also a little tab bar here at the top. We can use this to create separate sessions. So a new session, for example, and some little graphical glitches notwithstanding, this thing is fully separate from this default session that already existed. So let me actually start up my slides here and open a new session that connects directly to it. There we go. Let's get started. The terminal stack is composed of 3 layers. These live in the runtime, the Arvo kernel, and user space. The runtime is where everything involving old world terminals is handled. Arvo should obviously not concern itself with knowing about things like arcane terminal escape sequences. Instead, term.c listens for Arvo-style outputs and translates those into the appropriate output stream on the fly. It also translates input from the user for consumption by Arvo. Input here means not just keystrokes, but also things like window resizing. And with the coming update, it can detect mouse clicks as well. In short, think of the runtime as a client for Arvo's terminal. As a quick aside, all the input and output events and such, we'll look at their types in more detail after we've established the overall architecture. So when the runtime receives an input, it constructs the corresponding noun and sends this event into the kernel, specifically to DIL, the terminal vein. As of the coming update, every input also comes paired with the name of the session it originated in, so that the input can be threaded through accordingly. DIL has actually had a concept of sessions for a very long time. It just had never been fully hooked up. The coming update fixes this and reifies sessions through the entire stack. For every session, DIL is an associated user space agent. For lack of a better term, we refer to this agent as the terminal handler for that session. DIL maintains a subscription to this agent so that it can receive outputs from it at any time. Likewise, for inputs, DIL pokes the associated agent so that it may react as it deems appropriate. In some sense, that's all there's to it. That's the formal terminal stack. Everything outside of this, by virtue of living in user space, is free to change as it wishes. Of course, there are many other components in place that will likely remain important and prominent parts of the terminal experience for some time to come. So let's also look at how those relate to this. Right now, as far as terminal handlers go, there is only one. It is called drum, and it is a part of hood. Drum is the one responsible for the prompt that we're all so familiar with. It lets you connect to different applications, press Control X to switch between them. The only form of output it supports is appending lines to the bottom of the scrollback. We will look at how it connects to other agents a little later, but for now, the TLDR is that it mimics the stuff DIL does, just with a slightly higher level protocol. Important detail also to realize here is that Drum is not Dojo. Dojo is just the application that Drum is connected to by default. And it doesn't let you disconnect from the Dojo because you need it to manage your Drum session. For example, linking and unlinking to other applications. So while Drum and Dojo are a bit coupled, they're not the same thing. When someone says type into the Dojo, they mean type into that specific application, not into the terminal more broadly. There's also the web terminal, which is a bit of a unique case. It really wants to be the term.js sibling to the runtime's term.c, but the browser simply cannot connect to your urbit in the exact same way. Instead, what we do is make use of a proxy agent that we can interact with over HTTP using Air's built-in facilities. This agent, Herm, is barely 100 lines of code, and all it does is pass inputs between DIL and anyone subscribed to itself. This way, the web terminal still gets to be a client of DIL, just like the runtime is. The web terminal itself, in turn, uses xterm.js for simulating a terminal. It more or less directly ports all of term.c's functionality, only adding new bells and whistles where it feels natural. It's worth noting at this point that all of what we've talked about doesn't actually cover all the different kinds of output. This whole flow only covers formal outputs belonging to specific sessions. But there's two other paths by which text may end up on the screen. The first, and most similar to what we've seen so far, is that vanes and agents can independently tell DIL to display a message. This doesn't concern a specific session and isn't drawn in any specific location, but does still need to be drawn. DIL converts the message into outputs and sends them back up to the runtime. For an example of this, we can simply pass such an event to DIL to display some text that says hello world. And it gets printed as such. Even stranger than this, though, are slogs or sigpams or just debug printfs. These don't even happen formally within an event, but are just a side effect of a particular knock hint getting noticed by the interpreter. DIL doesn't know these happen. The runtime is entirely on its own as far as displaying them goes. In the upcoming release, we make output of this kind a light gray to more clearly separate them from formal outputs. You see some above in the scrollback here. And this is another example. In both of these scenarios, we have to answer a complicated question. Where can we draw this output? We don't really know the semantics of what's being displayed on the screen. Imagine you're playing a roguelike or, well, displaying slides for your presentation, and suddenly a debug printf eats into the layout that's on screen. We solve for this by making two guarantees. First, informal output like this is only ever displayed in the default session. This keeps other sessions safe from system output entirely. So if I go into the other session I created here and do another printf, It doesn't show up here at all. If we go back to the default session, there it is. Secondly, we assume that a default session, this one, is always connected to drum. That way, while we still won't know exactly what's on the screen, we at least know the semantics of it. At the bottom is a prompt, and everything above it is append-only scrollback. This means that to display a new line of output, we simply have to insert it between the end of the scrollback and the prompt. Yes, this still limits the capabilities of the default session, but short of taking the deep dive into logging reform, this is the cleanest way to handle the situation. The default session maintains the status quo so that we may experiment freely in all other sessions. As you've seen, the web terminal already has session support, and the runtime will follow suit before too long. With all that accounted for, let's now look at the protocols here in a bit more detail. Let's start by looking at input types. Yes, please, thank you. Let's start by looking at input types. Of course, we have our simple inputs, the individual keystrokes called bolts. Normal characters are represented as themselves. These are your letters, numbers, your symbols, anything that has a writable character on your keyboard. Other keys like arrow keys and backspace need special representations. Note also that mouse click support is included in the coming update. In the future, you might see things like mouse scroll events here too. Belts then are the full input type, containing potentially more complex form of inputs. Of course, the bolts are here. They're valid on their own, but also any of these bolts may be issued while a modifier key is held. We support control and meta, and both at the same time as hyper. We can also take chunks of text as a single input event, which may occur when pasting from the clipboard. In the upcoming release, you may notice that pasting into the real terminal is a lot faster than it used to be. Previously, we were treating every pasted character as a separate keystroke, a separate event, but now we handle those larger chunks of text all at once, resulting in a much faster turnaround time. So that's belts. What's the deal with these dill belts then? Belts are sent to dill by the runtime. Dill belts are what dill sends to the terminal handler agents. It's a superset of the runtime ones. You can see the regular belts included here. Dill simply adds some additional behavior on top. Arguably, some of these should be moved into the belt type proper. Window resizing, for example, is clearly a user input. The runtime should just treat it as a belt instead of having a dedicated task for it that dill needs to take pains to translate. Likewise for requesting a screen refresh. And, maybe even for connecting to an application, but that's more discutable. On the other end of the spectrum, though, is error rendering. It feels like an odd one out here and should maybe not be part of the input type like this. Wanting a pathway for that behavior, though, being able to tell the underlying application to display an error message is legitimate, but we may want to continue supporting it in a different way. Thus for all the different inputs. What about the outputs? How do we draw things to the screen? All of the operations here are very low level and do still betray some influence from their old world terminal origins. As a case in point, instead of having a single operation that says draw text at this location, we have separate outputs for moving the cursor to a specific location and then drawing text wherever the cursor happens to be located. Previously, the cursor could only move in one dimension at the very bottom of the screen. With the update, we can pick any location on the screen we want, opening us up to two-dimensional drawing operations. Note also how there's two ways of drawing text. We have put and color. Put is there for simple plain text. Color takes a stub instead, which is a data structure that lets us associate styling with the things we draw. We could make text bold, underlined, or even make it blink. And of course, we can specify any of the standard terminal colors or a specific color code for both the fore and background of what we're drawing. Aside from those core drawing operations, there are a couple more kinds of output. Bell simply makes a noise. Clear clears the entire screen. Nil issues a new line, which, if you do it at the bottom of the screen, pushes all other content up by one line. Sag and sav are there for file exports. In the real terminal, this writes it to your Unix disk. In the web terminal, this presents you with a download prompt. Likewise, URL is only supported in the web terminal, and when issued, opens a new window with the specified URL. Wipe simply clears whatever line the cursor is currently located at. And lastly, more is there to help us issue multiple outputs at once. We see the same pattern here we saw previously, where we have both a blit and a dilblit type. These dilblit outputs may be sent by the user space back up to dil, but rather than directly emitting these to the runtime, dil handles them specially. The only one of its kind right now is quit, which is used to shut the ship down, to stop the process. And that's all our outputs. Again, this is very low-level stuff. If we look further for just a little bit, we can see how Drum provides a higher-level protocol on top of these. I mentioned how Drum more or less does the same thing that dil does. It subscribes to other agents on a session path that get their outputs and pokes them with inputs as they happen. Drum is very opinionated, though, almost restrictive. It enforces much stronger semantics than dil does. It says that every application must have a prompt, and typing into that is the only way to interact with the application. And the only way of emitting visual output is to append a line of text to the bottom of the screen, just above the prompt. This makes it easy for Drum to handle multiple agents within the same session, but also means their outputs gets intermingled in scrollback. In return for this, though, Drum handles a lot of common command line logic, from editing the prompt buffer using various key combinations to remembering the commands you've run and letting you search across those. The individual applications it connects to don't need to concern themselves with implementing any of this. Drum's protocol is called SOL. Let's briefly look at what the types of this protocol look like. Inputs are described as SOL actions, which are targeted at a specific session. They contain either a change to the prompt buffer or some other user action like pressing return to submit the input or tab for autocomplete. Note how this is already very different from the low-level protocol we saw earlier. Instead of raw keystrokes, Drum gives us more semantically meaningful user actions. We have particular modifications of the prompt, and the SOL change type here is a bit bigger than you might expect at first. This is in order so that Drum may behave properly when multiple clients are connected to the same Drum session. Looking at the output types, the output type, I should say, SOL effect, we can see some familiar faces already. Bell and Clear are here, as are Sag and Sav. All of the other ones are clearly tailored to the specific experience Drum provides, though. With Pro, we can update the prompt. And with Air, we can point to a specific location in the input where an error has occurred. As far as drawing goes, we indeed are only able to append different kinds of lines to the bottom of the screen. Again, we have plain text and style text, and here we're also able to omit a list of tags. All of this is sufficient for simple command line applications, but is clearly not enough for richer terminal experiences like text editors, file browsers, and video games. Stepping away from Drum back up to Dill, with session support and the other improvements firmly in place, we finally have what we need to start working on those more free-form kinds of terminal experiences. In my mind, the most obvious first step is to make an alternative to Drum that leverages this newfound freedom. We want to detach ourselves from the prompt, from the command line, and move on to commanding an entire screen instead. Naturally, the 2D equivalent of Drum's prompt-only multiplexer is something like Tmux. This is what I've been hacking away on every Friday for the past month or two, urbit-Tmux. In case you're not familiar with what Tmux is, it's perhaps a little bit like a desktop environment for the terminal. It lets you run multiple applications at once, in separate windows, or even side by side. It's not quite ready for a demo yet. I'll leave that up to your imagination. But I can talk about how it slots into the roadmap for further work in this area. Right now, Drum doesn't let other agents draw freely. It wouldn't make much sense to, considering how multiple output streams intermingle. The only way to make use of the new functionality is to connect a session to your agent directly. Of course, that is the place where urbit-Tmux will live, connecting directly to Dill. Being in that place, though, forces you to work with just the low-level protocol, which is probably not ideal for general user space development. So, once urbit-Tmux exists, the next logical step is to have it support a custom protocol, like Drum does. Instead of moving the cursor manually for draw operations, you'd just be able to tell it what to draw where. Maybe you can even give it a 2D buffer to draw, or, get this, tell it about UI elements. We probably won't be able to go full UI protocol right away, but it's not too crazy to imagine. urbit-Tmux already needs many related things for its own implementation. Scrollable buffers, text wrapping, selection lists, clickable areas, and so on. Though not exactly a new area of computer science, right now this kind of native UI is still uncharted territory as far as Hoon applications go. Within Tlon, patterns for implementing native UI have come up on a couple of occasions. There's some interesting ideas floating around about rendering UIs statelessly by making use of the scry namespace. Instead of having applications do the potentially standardized rendering themselves, a sufficiently advanced client could scry out the data structures that need to be rendered and only interact with the application statefully for user input. If you do this in such a way that you can optimistically reflect the state changes in the client, you're suddenly much less hampered by the event loop overhead. The nice thing about all of this living in user space is that we have a large amount of freedom in our experimentation. We can set up and tear down new protocols without touching the kernel. If we wanted to make radical reforms to the lower level protocol, we could first try it out with a couple of apps and a dedicated client, instead of needing to modify Dill and the runtime right away. Of course, we're still not done with changes and improvements in those areas either, and we will eventually need to address that for a more complete experience. Right now, the runtime still always connects to the default session, and it's not possible to connect to an already running urbit. And we will at some point need to more fully resolve the question of how to deal with debug printfs. Perhaps the time for logging reform, is near. Additionally, as we've seen, the input and output types could use some further cleanup and also just don't feel quite complete yet. We have file exports, but cannot provide a file as input. We can paste text, but cannot copy any into the clipboard. Would we want to detect presses of the function keys? What about buttons on a game controller? How much can and should we generalize here? And what things should be left up to dedicated clients? There are still many open questions like this, but I don't think we've ever been in a better position to grapple with them than we are now. After a long hiatus, Urbit's terminal experience is finally moving forward again, and I'm excited to see where it ends up. Before I move on to questions, just a little bit of housekeeping. If you have previously published a command line application on Urbit, the coming release has a breaking change you'll need to account for. Please see the urbit-dev mailing list for the details on that. I put a URL on screen here. It should also be in the video description. For those of you looking to dive into the changes in more detail, I've put the relevant pull requests on screen as well. These should also be in the video description. So thank you all for your time. And if there's any questions, I'd be happy to answer those here or on the network.
All right, thank you. This is exciting. This is going to enable us to do a lot of things that we're not, that are currently fairly difficult to do. Now, one question I had was, what about, you kind of gestured toward this with talking about dealing with game controllers and the like. What is the status of special keys? Are these parsed by the host operating system, or are these passed through things like function keys and other control keys, or are these actually caught before they reach the Urbit runtime?
Yeah, so these are, this depends on what keys you're talking about. And of course, what kind of terminal emulator it is you're running your Urbit in. For things like arrow keys, there are special escape sequences that these get turned into that the Urbit process can read. But for example, the escape key in many terminal emulators is handled specially, not as a keystroke, but as a marker that says transform the next keystroke in some way. This makes it difficult to, in real terminals, capture the pressing of the escape key, for example. Function keys and media controls and that kind of stuff suffers from the same issue, that terminal emulators don't let us read those gracefully.
Will we see support in a library like Sol for color control and output?
Color control and output is already there. You may have seen
the escape sequence now to do it, right?
Oh, yeah. So you don't even, if you, for example, the blue and green you saw on screen, we don't even issue the escape sequences for that. We simply say, here's some text. The background is green. And then that bubbles all the way up to the runtime, where the runtime has some special knowledge of how to display text with green backgrounds.
Okay, let me check the current questions here. One of the questions that kind of arises through all of this is basically, tell us about the stack you were using to present there inside the web terminal.
Yeah, so, and I don't know if my screen is still sharing. I don't think it is.
There it is.
Yeah, so the thing I'm doing right now is the same that urbit-tmux is doing in this screen, where you saw me at the very beginning press this, and instead of typing a session name as is, I typed an agent name followed by zap and then the session name. This is a little Easter egg we put in to make testing things like this easier. And all that means is saying, instead of creating a session that opens in Drum, as sessions do by default, we connect to a specific application. And so for this presentation, I wrote a very small application that just has my slides hard-coded in this and a little functionality that lets me click around and highlight certain parts of it. Arrow keys for navigation. That's it.
Can you talk a little bit about mouse integration as well? That was something that had been talked about at one point and asked about.
Yeah, mouse integration is actually interesting because while we do support mouse integration right now, it's a little bit hamstrung if you're using it in the real terminal. So there's many different ways for command line applications to signal that, hey, I want to receive events from the mouse whenever they happen. At the very lowest layer of possibilities, you can listen to just mouse clicks. You don't even care what button was being pressed. If you take that to the other extreme, you even get events for the mouse simply moving across the screen, and you can detect clicks and drags with different buttons and so on. For this initial version, we only wanted to put in just the simple mouse clicks. But it turns out that not all terminal emulators support reporting that properly. So in the web terminal, you've seen it works fine. But if I try this on my own terminal emulator, on my desktop, it doesn't actually report the clicks. It only starts doing that if I also ask for clicks with other mouse buttons and scroll events. This is something we don't yet want to do. If you're messing with someone's scroll events, you could prevent them from scrolling back up in their buffer to see, what messages just rolled off the screen. So until we have, native scrollable buffers, as urbit-tmux will provide, we won't be listening for mouse scroll events just yet.
Yep. I think this will have a related answer via terminal emulators, which is Eric asking about, can we make different noises with the bell? And of course that's...
Well, yes, you can. So the way the bell works is, again, it just goes up to the runtime or the web terminal, wherever you're running, and that knows oh, I need to make a sound. Your terminal emulator probably uses whatever bell noise you have configured for your operating system. In the web terminal, we ship with a teeny tiny sound file that's like a beat on a xylophone, something similar to that. And that's what we use for the noise instead. So if you want it, you could patch WebTerm to make a different noise instead, and that would work just fine. Controlling that from within Urbit is a different story, though.
Mm-hmm. Now, another question that I had was, so DIL is a terminal vein, not really a keystroke vein. And I'll get to the distinction a little bit more in just a moment. And so where would you draw the line between terminal-like apps and other kinds of command line-like interfaces? So for instance, a Google search bar or an Excel window is a command line, even if we don't classically think of it as a command line in the same sense as Bash. So what should we think about pushing to DIL or drum as opposed to implementing other kinds of ways of interacting with it?
Yeah, this is a good question. Also because it's it's still a little bit up in the air. DIL has historically been called the terminal vein, and so I just use that name here. But it's it's already not quite a terminal vein because it doesn't know about, oh, escape sequences this and that, right? It tries to detach itself from that a little bit. Mm-hmm. And then when you come to thinking about what is a command line, it's well, okay, yes, Excel is a command line, I can see that. Google search is a command line, I can totally see that. I can also totally see rendering those as text UIs, and then suddenly many more things come into view. Right now, because of its historical baggage, I would probably call Dill the text UI vein, just because that's what it knows. It assumes there's like a matrix within which text of various kinds gets drawn to the screen, and doesn't associate any semantic information with that. If you we talked a bit about the UI protocol stuff, and it's like, yes, maybe Dill should know about the primitive of this is a button, and if you click it, this other thing happens. But we're not, that's like very far from where we are now. And before we even think about moving that into the kernel, we should thoroughly experiment in user space and see what's possible and practical to use for developers on the Arvo side, and then build clients for on Earth.
Okay, fantastic. Tiddler Tolbus asks, will we be able to send commands to the dojo from outside of Urbit?
Yes, that's not strictly related to this line of work. Again, Dojo is just an application, and so if it had an HTTP endpoint for sending commands, that would work just fine. What we've also recently added is a control plane vein called Con, which provides a Unix socket for your for accessing your Urbit. Using that, you're able to do things like start threads and poke into different applications. And so you can imagine sending a Dojo command that way. Of course, historically, we've also had a strange hack where using some loopback HTTP endpoint, you could send, I wouldn't even say send keystrokes, but type commands into a script that then gets sent to Drum, I believe. And that way you could interact with Dojo also. But that was much less formal.
We're going to have Jake Miller on in August to talk about Con. So we'll get to Con more in the future as well and see how that works. So how far are we until someone implements native Zork on top of Urbit? I think that's the question.
That's a game engine, right?
Yeah, that's a well, right. So there's the Zork machine that you could pretty much write. There's an interpretive language, ZIL, that all the files are written in, and then it's just basically writing a front end and a back end interpreter and stringing the two together. You don't have to re-implement the game; you have to implement the engine.
Yeah, that's cool. I've read about that. It's over the years, it's come up in discussion in Urbit community a couple of times, and it's still somewhere on my list of oh yeah, if I have tons of extra time, I should definitely look into the spec of this thing and just make an interpreter for those game files. Because then suddenly I know there's a couple different official Zork games and versions and such, and people have made new content using that also. And so then all of that suddenly becomes playable within your Urbit, which is of course very, very exciting.
Let's see, another question here. Is there a good way to copy paste output from WebTerm?
Yes, there is. And as of the upcoming release, there's a little information thing in the top right that you can click to find out how it actually works. This is, again, because we capture mouse inputs, click and drag doesn't work as is. You need to hold either Alt or Shift, depending on your operating system, and then drag across the screen to select text. After that, copy works fine. And then, paste is just, as I mentioned, large chunks of text that get handled as inputs by the web terminal.
All right. I think we've about run through the questions that are here, and I've certainly learned a lot about how this is working. I've messed with Dill before, but mostly it's been at the level of pushing around Blitz and working with the belt a little bit.
Mm-hmm.
So this is getting much deeper into that. So we are going to have a Hangout session after the talk now. The Google link is on the screen right there. And so next month, we're going to have a dev call about DAO tooling with Trent at Holium and get into some details about what they've been working on. And then in a couple months, we'll talk about Con, and then we're leading up to assembly in September. So once again, thank you, Mark.
My pleasure.
And I'll leave that link